Cito, strike one! Never mind, leave it right.
Mr. Park, why didn't you have any of those problems on the test map? You know, the true one guy's right.
Yeah. Stop listening to it.
Oh, no, you know those ones where it's like, if one
Well, you
guy-
need logic puzzles.
How come you never put those on the test? But you kind of still work.
That was just for fun. They'll still have fun. Okay, here are the worksheets for the next chapter. I know you told me. I've done this a few already. I know, but you're gonna get one. Linear and quadratic functions. How hard can this chapter be? Some reason, like I told you, the average is going to plummet. And as expected, the average was 95 on yesterday's test for all three classes.
Wait, all three of us had 95?
And separately.
It's really weird.
No, I don't care. Oh. Okay, now what do you need to know for tonight's homework? Now look at. Now, does everybody have their graphic calculator?
Yeah.
See, because tonight, we'll just see what happens. Okay, the things we're going to do with tonight's homework are basically as part of a category called Analytic Geometry. Analytic Geometry is kind of combining algebra and geometry together, solving geometry problems using algebra. So by putting geometric figures on the Cartesian plane, you guys know what the Cartesian plane is?
Yeah, it's the one.
It's the plane formed by the x and the y axis, right? It's called the Cartesian plane. But why do we call it the Cartesian plane? Exactly. In honor of the French mathematician René Descartes. Okay, now, once you learn to plot points in the Cartesian plane, right, then you can do things, right? You can form lines, triangles, quadrilaterals, yeah? And then when we get to the third quarter, then we add the z-axis in, then we can do three-dimensional things. Okay, so there are certain formulas that you already learned, okay? Like, for example, what is this formula?
Hero.
This is the distance between 2 points in the Cartesian plane. What do I use this formula for? Yeah, that is to compute slope between the slope of a line connecting 2 points in the Cartesian plane. What is this formula? This is how you find the midpoint between 2 points in the Cartesian plane. And that's pretty much all you have to know on tonight's homework. We're not even going to write an equation of a line, because right now that's too difficult. Wait till you see tomorrow's homework. What's so hard about writing an equation of a line? I don't know. There's nothing hard about it, but I don't know. There's something happens. So, I don't know where your algebraic skills are right now. Okay, here's a continuum. Okay, let's say this is algebra skills. 0 and 1. 0 is like non-existent and 1 is like you're the best in the whole world. Where are you? 0.1. And maybe that's why. Maybe that's why we have such a hard time. Because analytic geometry, you have to do lots of algebra. So I don't know where you are, but by the end of this chapter, you're going to have to be around here. That's where we're going to end up. I mean, unless, well, I mean, if you just do the homework, that's where you're gonna be. If you don't do the homework, you just copy and stuff like that, then you're just gonna stay there, and then when the test comes, you're just gonna start crying. Okay, so let's look at some problems then. Okay, what kind of problems could I give you? Okay, silence, I need silence. Okay, here's the origin. Here's the point, -4, 2. And then, right, the point 6, 3. Okay. What did I just say? Okay, I'm just making up these things. A, B, C, D. Okay, these 4 points form a quadrilateral. Okay, using only the distance formula. What kind of quadrilateral is this? You can only use the distance formula. So what should I start doing?
Using a distance formula.
Yeah, you use the distance formula. To do what though?
Find the distance.
Okay, so let's start off. What do you want to do first? AB?
Yeah.
Yeah.
Okay, using AB. Okay, by this time already, you guys should be able to just do it in your head, right? Love.
Oh, you mean the whole thing?
AB? Oh, okay.
Root 20.
Which simplifies to?
2 root 5.
Did everybody get that? Can you guys do this in here though? Just go. What is the difference of the x coordinates? 4. What's the difference of the y coordinates? So you got 4 on this side of your brain, 2 over here, square each one. 16 and 4, add them together 20, and then radicalize. In this is honors, people. We are not gonna do, if I see anybody do this, I'm gonna scream. Oh, square root of -4 minus 0 squared plus 2 minus, I'm showing all my work, Mr. I don't wanna see work. Square root of minus, okay, that's -4 squared, 2 minus 0 is 2 squared. So that's the square root of -4 squared is 16 plus 2 squared is 4. So that's the square root of 20. But 20 can be written as 4 times 5. So that's the square root of 4 times the square root of 5. 2 root 5. If anybody does that, you're not going to survive. You got to be able to do things in your head. Well, maybe you can, at least can you get to there? The more things you can do in your head, the better. Okay? Okay, next one, BC. Who's got BC? Die.
2 root 5.
What?
He did it hard.
BC?
Oh, BC. Oh, BC. Sorry.
We have 2 boards right there.
45. Root 45. No.
Yeah, but yeah, it can be simplified too.
Simplified to 3 root 5.
Okay, there you go. Okay, now CD. Ow.
2 root 5.
And then AD. Who's got AD? BC. Yeah, you got the 0. The 0 is the easy one. Why are you looking down at the paper?
3 root 5.
Okay, 3 root 5. Oh! So, Mr. Park, this side is equal to this side. And this side equal to that side. Oh, so what can we conclude right there?
Parallelogram.
It's a parallelogram. It might be a rectangle though. It might be a rectangle. Just because the opposite sides are equal, that doesn't mean it's automatically a rectangle, right? It's a parallelogram. Now, how do we check to see if it's a rectangle? Because it could be a rectangle. You check the... No, you cannot use slope. See,
Check the.
that's it. That's what I'm going to tell you. You're not listening, Morris.
Diagonal.
judging from what I saw on your test, you're just not listening.
Oh, you're gonna give us back.
You check the diagonal. I always give the test back at the end, after the lecture. You know why?
So we don't think about it.
No, no. Well, kind of. Because if I give it to you before the lecture, then some of you will get all depressed. And then you have to listen to the lecture, and then the vicious cycle starts. So it's always at the end.
That's so true.
No, yeah, that's why. Okay, AC. Okay, so now we're gonna check the diagonals. AC. Toby. You got the 0.
Root 29.
Okay, root 29. And then BD, Ching. Yeah, there you go, root 101. So is this a rectangle? No, because if this were a rectangle, wouldn't the diagonals be equal? If they're not, so therefore, this is a parallelogram. Okay, what if I said, okay, erase. What if I said, now you can only use slope? The only thing you can use is slope. What kind of quadrilateral is this? What do you think I'm going to start doing? I'm going to compute slopes. Okay, so what's the slope of AB? Park. I'm just trying to. That's 0. If you have
Negative.
negative what?
No. Wait.
Y minus y over x minus x.
Oh, why? Oh. Negative half.
Negative half. Okay, what's the slope of BC? Well, I mean, if you try your picture, like kind of accurate, then look, that's a positive slope because it's going uphill, right? So all you gotta do, what's the difference of the y's? 3. What's the difference of the x's? 6. So 3 over 6, 1/2, right?
Right. Okay.
Some of you are so worried about the sign. How about just look at the differences and look which way it's going, up or down? Okay, what's the slope of CD? You know it's going to be negative because it's coming downhill, right? What's the difference of the y's?
2.
What's the difference of the x's? 2 over 4, 1/2. Do you guys ever do things like that? Or do you have to do it? Y minus y over x minus x. I guess that works too. What's the slope of AB? Yeah, how did you do that so quickly?
It's a parallelogram.
Did you actually compute it or are you playing the game?
Playing the game.
Okay. What does that mean, playing the game?
Pretending like you're actually doing it, but you're not.
Okay, exactly, good. You know why? Because we already proved it's a parallelogram, so doesn't that slope have to be the same as this slope? So you pretend you compute and then you just say 1/2 because it's got to be the same. So if 2 lines have the same slope, that means they are parallel. So if the opposite sides are parallel, what can we conclude? It's a parallelogram, but it might be a rectangle, right? So how do I check?
Perpendicular stuff.
You look at the diagonals. Yeah, but even then, that doesn't prove any. Okay, well, let's just do it. What's the slope of AC? Look, you got the 0 in it. 5 over 2. What's the slope of BD? 1/10. Okay, they're not perpendicular. How do you tell if they're perpendicular?
Negative, I mean, opposite.
Negative reciprocal, but they're not. Okay, so does that even tell us anything? No, it's not square. It's not a square, there you go. Or a rhombus. But a rhombus is what am I saying? A rhombus is a parallelogram, right? So how do you check if it's a rectangle then? Yeah, but see, you check this and this. If this slope is 1/2 and that's negative 1/2, they're not negative reciprocal, so there's not a right angle there, so it's not a rectangle. You know what I mean? Okay, so these are the tools you have on tonight's homework. You got slope and you got distance formula. That's pretty much all you need. You put those in your tool belt and let's see if you can solve some tough problems. Yeah. Okay, now let me see the homework, because there's one problem, look at your homework. There is one problem you're gonna get to use your calculator on.
Over here.
Which one do you think it is?
Number 5.
It's number 5. It's, okay, in fact, you guys wanna do it together?
Yeah.
No.
Can I assume you guys know how to use your calculator?
Yes.
Yeah.
No. Yes.
Yeah.
Just to compute numbers?
Yes. Yes.
Okay, you know what, I changed my mind. I'm just gonna make up a problem. Similar to them. So just give me some numbers. Okay, here's a triangle in the Cartesian plane. A, B, C. Give me some numbers, go.
7.
0, 0.
Okay, 0, 0. What about this one? 7, comma 2, kind of looks like it. What about up here?
63,
3. No. It's gotta be smaller than 7. Okay, 4 then. 4, comma, it's gotta be bigger than 2.
3.
6.
3, 63.
63.
No, okay, 63. What kind of numbers are you guys? Okay, now, there are several ways you can compute the area of this triangle. If you were in my summer school class, I taught you, right? Put the box around it, right? Right? If you put the box around it, then you just find the area of the rectangle, and then you minus these 3 right triangles, right? Okay, but I don't want you to do it that way. I want you, well, if you look at the directions in your homework, it says use Heron's formula. Okay, what is Heron's formula? That's how you find the area of a triangle if you know the 3 sides. Does this look familiar? Area equal, now usually in mathematics we use the Greek letter kappa to represent area. Kappa equals square root of s times s minus a times s minus b times s minus c. Everybody saw this in geometry, right?
Yes.
And what is s equal to? Semi-perimeter, half the perimeter. So then what do I have to know to use Heron's formula? You gotta know the 3 sides, and how do we figure out the 3 sides? Distance formula. Yo, Mr. Park, when you use the distance formula, what is this? Square root 53, that's ugly. What about this one? You know what, I changed my mind. I'm gonna change this number to an 8 because the numbers are too nice otherwise. I want ugly numbers. What is that? Root 80. Should I simplify that? Yeah, just leave it. I think it's easier to punch it on your calculator if it's like that. What about this one? 3 and 6, root 45. Ah, these are too nice. You see what I'm doing? I just take the difference of the x's, which is, take the difference of the y's. So 3, 6, square them. 9, 36, add them together, 45 square rooted. Instead of practice. Okay, Mr. Park, look at all these ugly radicals. Because if you put the box around it, isn't the answer going to come out nice? If you have integer coordinates and you put the box around it, isn't it all going to come out like nice, the answer? Or at the worst, 0.5, right? Something 0.5. But then look, I get all these radicals. How the heck? Okay, here, take out your whatever calculator you have. Do you guys know how to store in your calculator? Okay, I'm talking about the TI calculator now. How many memory locations do you have in your calculator? What's that? That's where you can actually store a number. You have 26. Well, actually, you have more, but I'm just going to make it simple for you. You have 26, one for each letter, A through Z. Okay? So, what if I want to store this number in memory location? Where, in fact, what do you think I'm going to store this in? Very good, because this is side C, this is side A, and this is side B, right? Remember, side A is opposite angle A. You guys learned this in trigonometry, yeah? So how do I store radical 53 into memory location C? You just go like this, square root 53, store it in C, and press enter. Ka-toom! Mr. Park, where's the store button? Look for this button, store! You guys obviously never used that before. Store. I want to store that in memory location C. How do you get C, Mr. Park? Alpha C. Alpha means you're going to use the alphabet. Alpha C. Are we having problems, Park? The letters are above. Okay, what calculator is this? There, the C is in red. Alpha, C, alpha, C. No, 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 no! Ah! Okay, you have the prism. So once you get here, you gotta like go past that.
Oh, yeah.
I don't know what you gotta do. Press the right arrow or something.
Yeah. Yeah.
Okay, but if you have TI, just punch it in like this. Morrissey. No, not Morris. What's the problem? Oh, you guys! Okay.
Oh, I got it.
No, 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 no. Yeah, you got it, but
Yeah.
okay. You know the newer calculators, they want to make it look real like this, right? How many of you have the newer calculators where you can do that? TI. Who has the older ones where you gotta do this? Okay. Now, if you don't like this new notation, because I don't really like it, I'd rather do this one, then you know you can go back to classic mode and you can do this. Try to look at the press mode. Is it one of the things classic? Press the mode button. Try to look for classic. Is one of the things classic, yes or no? Well, the old calculators are not going to have it. Okay, the newer ones. What does it say? Classic mode.
Oh, I see it.
Yeah,
Go to the menu and then go to like.
This is alternate.
You guys! Okay, continue. Let's do it. Okay, what about radical 45? Now do this. Square root of 45. Store that in A. Press enter. If you don't press enter, it's not going to store it. Then you do square root of 80. Store that into B. Press enter. Now all of these numbers are stored. Okay, on the Casio, did you figure it out yet? There's no store button.
What do you do once you store it?
What?
What do you do once you store it?
Just leave it there. It's in there forever until you get rid of it.
Well, how do you find it?
No, 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 no. What do you mean it doesn't work? Try press C now. Just press C. Press C and enter. Woo! It works! Tell them how to do it.
So what do you have? You don't have the server?
Oh yeah, the alpha C.
Okay, this is my feeling right now. You guys only know how to crunch numbers. You guys don't even know the buttons on your calculator. All you can do is add, subtract, multiply, and divide, and play Tetris. That's all you can do. That's all you know how to do right now. Because look, okay, think about it. What if you have all of these ugly numbers, and then you have to punch it into this formula?
Right.
Isn't that going to be kind of messy?
Okay.
Oh, I see.
Yeah. Okay, so you store the numbers. Now, these numbers, that means from this day until you get rid of it, anytime you press C on your calculator is going to substitute this number with all its decimal places for C. You know what I mean? So if you punch in A, B, C on your calculator and press enter, it's going to multiply this times this times this. How do I get rid of it, Mr. Park? No, you don't. It's going to stay there until you replace C with a different number. You know what I'm talking about? Oh boy. Can't believe we don't know that. Okay, now what do you think I'm going to do next? I'm going to do A plus B plus C divided by 2. I'm going to store that into T. No, S.
S.
That's the semi perimeter. What am I dealing with here?
That's so hard.
No. Okay, now that I have S, A, B, and C, all I have to do is tell my calculator what? If I want to compute the area of this triangle, what do I tell my calculator now? Compute the square root of S times S minus A times S minus B times S minus C. Press enter, and the calculator is going to plug all these numbers in, and boom, it's going to spit out the answer right there. Now what do you get? It's either going to be an integer or something 0.5. It's 24. 24? Whoa! How do you punch in all these ugly radicals and the answer comes out 24? Okay, somebody impress me. Why is the answer going to be either an integer or something 0.5, even though you get all ugly radicals? How? Why? How and why? That's a duh. Of course they're going to cancel each other. But why do they? Okay, I'll let you think about that. Maybe that's a bonus on the next test. Maybe that's a regular problem. Okay, now, so yeah, but Mr. Park, what if do another problem. Okay, so what if I store some different numbers in? So you don't have to do this. Like what if this one comes out root 73, this one comes out root 109, and this one comes out root 211. I still have to do this and this and this, huh? Well, once you store these in, okay, you gotta get the new S, but you don't have to punch it in again. Do you know that in your calculator you can go back up to all your previous computations? How do you do that? What button do I press? Sure, look at the buttons on your calculator. Okay, look at, is there a button called entry? Lower right hand corner. This is TI. If you got the prism, you just gotta hunt for it on your own. Okay, try press the entry button. What happened? Yeah, it spit out the last thing you computed. And you can keep going back. So you keep pressing entry until you get back to this one right here. Try to do it. Keep pressing entry until you get back to this one. And then once you have these stored there, you just press enter again. Now you got a new S. And then you keep pressing entry again until you see this in your calculator. And then you just press the enter button and it plugs these in and boom, you get the new area. So you don't have to keep reinventing the wheel. You know what I'm talking about? You just like to keep typing in from the beginning.
Yeah.
Who told you guys to get a Casio calculator?
School.
Yeah, but then did you also get the manual? You gotta download it. You have to go to the website and download it, because I have it on my computer. Okay, lesson number 1. Get a calculator you can use. No, that's okay. That's a good calculator. You just gotta learn how to use it. Okay, if you absolutely don't know anything, if I need to find out something about a calculator, this is what I do. I go onto Google, I type in Casio, what is it called, Prism, and then type in store, and see what comes up. Why are you staring at me? Try it. See what, it'll tell you how to store it. Right now, I don't know. I'm an expert on the TI. I'm not an expert on the Casio.
Like where you can buy one.
Buy what?
Like,
Why?
Google
Personal
that.
store.
It'll come up with the store.
Not go to the store. We're talking about storing numbers and variables. Okay, so tonight's homework is supposed to be easy because we're not even writing equations of lines. You're just using distance formula and slope. But I've been teaching this class for 26 years. There's going to be problems. I know already. Okay, test. The class, the average was 95. I told you it was going to be.